Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Generative Adversarial Networks. GANs. AI artists that create hyper-realistic images. Imagine an AI that doesn't just understand images, but can actually create brand new, incredibly realistic images from scratch. That's a generative adversarial network. Or GAN. Think of GANs as digital artists that can generate faces of people who don't exist, produce unique landscapes, or even design fashion items. All with stunning realism. They've revolutionized what AI can achieve in terms of creativity. To understand GANs, let's use an analogy. Picture a cunning art forger, our AI generator, trying to create fake paintings so perfect they fool an expert art critic. Our AI discriminator. The forger keeps creating fakes, and the critic keeps trying to spot them. Every time the critic is fooled, the forger learns to make even better fakes. Every time the critic spots a fake, the critic learns to be sharper. This ongoing, competitive game is the secret behind how a GAN learns and improves. In a GAN, our forger is a neural network called the asterisk generator. Its job is to take random noise, like static on an old TV or a blank canvas, and transform it into something that looks like a real image. Initially, it's just guessing, producing blurry, nonsensical images, but it has one goal: to improve its creations so they can fool the discriminator. It's like an aspiring artist constantly practicing and trying new techniques. Our art critic in this setup is another neural network called the asterisk discriminator. Its task is simpler but crucial. Given an image, it must decide if it's a real image, taken from our actual dataset of genuine photos, or a fake image, generated by the generator. The discriminator is initially trained on a mix of real images and the generator's early, poor fakes, learning to tell the difference. It's the gatekeeper, judging the authenticity of every piece it sees. This is where the magic happens. The generator creates a batch of fake images. The discriminator then looks at both real images from the dataset and these newly generated fake images, trying to correctly label each as real or fake. Asterisk. If the discriminator correctly identifies a fake, the generator gets feedback that its fake was not good enough, and it adjusts its internal settings to produce more convincing fakes next time. Asterisk. If the discriminator is fooled and labels a fake image as real, then the discriminator gets feedback that it made a mistake, and it adjusts its settings to become a better, more perceptive critic. This constant, competitive feedback loop drives both networks to improve dramatically, pushing the generator to create astonishingly realistic images. Once trained, GANs are incredibly powerful. They can generate hyper-realistic faces, create portraits of people who don't exist, but look completely lifelike, art and style transfer, produce unique artworks in various styles or transform photos to mimic famous artists. Image-to-image translation, convert sketches into realistic photos, day scenes into night scenes, or even change seasons in an image. Data augmentation, create vast amounts of new training data for other AI models, especially useful where real-world data is scarce. Image super resolution, upscale low-resolution images into high-resolution, sharp versions. It's like having an infinite digital canvas for AI. For developers, understanding GANs opens up a new realm of possibilities. You can train a GAN on a specific dataset, perhaps architectural designs, specific fashion items, or even medical images, to generate new, original content in that domain. You'll typically work with AI frameworks like TensorFlow or PyTorch, defining the neural network architectures for both the generator and discriminator, and carefully managing the iterative training process. It's a challenging but incredibly rewarding experience to program an AI that can truly create. GANs are a leading example of generative AI that creates rather than just analyzes. They've pushed the boundaries of what AI can accomplish, moving us closer to systems that can exhibit true creativity. While they come with their own set of challenges, like requiring significant data and careful training, their potential is immense. Keep exploring, keep building, and soon you might be training your own AI artist, making digital dreams a reality. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.